Okay, today I'm going to talk to you about balancing equations using masses. We're going to have a look at this question here and how to write a balanced equation giving this information. So the question says Paula burns a metal X in oxygen. So this is just an unknown metal, this X. There is a single product, an oxide of the element. Given that 25.4 grams of X burns in 3.2 grams of oxygen, write a balanced equation. We're also given information about the atomic mass of X and the relative formula mass of the oxide. So it seems quite complex. We're going to do the step-by-step process of how to figure it out. So the first thing I'm going to do is I'm just going to try and summarise this information with a basic equation. Not balanced yet, but just a basic equation. So we've got the idea of X is reacting with oxygen, which is O2, to form an oxide of X. So just by writing this simple idea out, I've got in my head what's going on. These are reacting together to give this. So my next step, what I have to do is I'm just going to write down the other information I have about the masses. So I know I've got 25.4 grams of X and 3.2 grams of oxygen. So just underneath each one, so I know which mass is applying to which one, I'm just going to write them underneath, 3.2 grams. So my next step is this. If I start off with 25.4 grams of this and 3.2 grams of this, the mass of the oxide produced must be the sum of these two. So I need to add them together to find the mass of that. Because no atoms are created or destroyed, the masses of the reactants must add up to the masses of the product. So this is 28.6 grams. So now I've got the mass of each of these. What I'm trying to do now is I'm trying to find the number of moles. So I can use this equation triangle here. This comes in handy a lot of the time when we're using moles. So M stands for mass, which is measured in grams. N stands for the number of moles. So that's just the number of particles reacting. And MR stands for relative formula mass. Now this could also stand for relative atomic mass, depending on what we're talking about. So what I'm going to do first of all is I'm going to try and find the number of moles of X right here. So to find the number of moles, I need to do the mass divided by the relative formula mass. So in this particular instance, I'm going to do the mass, 25.4, divided by the relative formula mass of this. Now the relative formula mass is given right here. I'm told what it is right here. So it's going to be 25.4, so I'll just get my calculator, 25.4 divided by 63.5, and the answer is 0.4. So the number of moles of this is 0.4. Now, I'm going to do the exact same for this. So to find the number of moles of oxygen, of O2, I need to do the mass divided by the relative formula mass. So 3.2 divided by, now because I'm not given this information, I have to use my periodic table. So the relative atomic mass of oxygen is 16. So because there's two of them, it's going to be divided by 16 times 2. Or simplified, that's 3.2 divided by 32. Because that is what 16 times 2 is. So 3.2 divided by 32 is 0.1. So that is the mass, the number of moles of that one. And finally, for my oxide of X, is the number of moles. Again, use this equation triangle, the mass divided by the relative formula mass. So my mass is there that I've already worked out. 28.6, and I need to divide it by the relative formula mass. Again, I'm given that number here, 143, so I'm dividing it by 143. So I'm going to use my calculator. 28.6 divided by 143 is 0.2. So for my next step, you might be able to, because basically what we need to do next is see the ratio between these different numbers. Instantly, you might be able to see it. So for example, you might be able to see that 0.4 to 0.1 to 0.2 is 4 to 1 to 2 ratio. However, if these numbers aren't as kind as this, what you can do is this. You find the smallest number of the three and you divide each one by the smallest number. So let's just quickly do that. So to find this one, you need to do 0.4 divided by 0.1, and that equals 4. For this one, you need to do 0.1 divided by 0.1, which equals 1. And for this one, you do 0.2 divided by 0.1, which equals 2. So all I've done to each of these is divide by the smallest number. So 4 to 1 to 2 ratio. That is going to tell me what numbers need to go in front of each of these in order to balance the equation. So now I'm nearly done. So I'm going to look at the kind of rough equation that I've written here in order to sort me out. So I know that there's going to be 4 atoms of this. So it's going to be 4x. I also know I'm going to have one O2 because this number here is for O2. Notice how with all of my calculations I've written them exactly underneath each one so not to get confused. So if I've got one O2, I'm just going to write that as O2. Now, the next bit is to find the formula of this oxide. Now, I know for a metal oxide it's going to be X and O. Now I don't know how many X's there are going to be and I don't know how many O's there are going to be yet, but I know that there's going to be a 2 in front of it because I've got this number right here. It's showing I've got 2 lots of my metal oxide. So all I need to do now is figure out how many X's I have and how many O's I have. To do that, I need to make sure it's balanced to this side of the equation. So I know I've got 4 X's. So if I've got a 2 in front of here, I know I must have 2 lots of X to make 4 in total. On the left-hand side of the equation, my reactants, I've got 2 oxygen atoms. Now, because there's a 2 in front of here, I know I've already got my correct number of oxygens, so I don't need to put a little number here. So as a result, that is the balanced symbol equation right there. 4x plus O2 goes to 2x2O. So that is how to balance equations using masses. Thank you.